Hey guys, welcome back to my channel, and today we're going to be considering the events. An event is a subset of the sample space. That said, it is a set of possible outcomes. If the outcome of an experiment is an element of A, we say that this event A has occurred. And the event, which consists of a single point of S, is often called a simple or elementary event. So for example, here is the A. A is the event of sample space, because it is the set of possible outcomes. That said, each element which belongs to event A will also belong to sample space. And here's an important distinction between A and S. Not every element of S belongs to set A. Later in videos, we're gonna consider Euler diagrams. Euler diagrams is really important thing to illustrate the events, because all the probability theory is based upon sets theory. So suppose we have an event A, which is illustrated as this Euler diagram, and suppose we have some event B, and we may have the sample space as a rectangular sample space here. So we can say that if our element A occurred, the element of A possible outcome of A has occurred. That means the S occurred, because it essentially inside the S. If this element occurred, if this possible outcome occurred, that means A also occurred, because it is inside the A, but it is not inside the B. There exists some X from the S, which might or might not belongs to A, or X belongs to B, but this is not guaranteed. Let's take a look at the practical examples to understand this better. Suppose we toss a coin twice. The event that will only one head comes up is the subset of the sample space that consists of points 0, 1, and 1, 0. Let's try to illustrate this. For example, the only one head comes up. So the first one is tail and head. The second one is head and head. The third one is head and tail. And the first one is tail and tail. Now, only one head comes up, one head. So this one head. And this point as well belongs to one head event. And they make up a whole new set of events, which is called the union of event A and event B. This is event A and event B. And we can consider the union of A and B as the event C. The event C is essentially the event that only one head comes up. This is it. And now we can say that event C is the subset of S. Now here are two more important definitions here. The first one is a sure or certain event. The sample space itself is called a sure or certain event because it is always happening. No matter which value you choose, no matter which event occurs, the event S itself, the sample space, must occur anytime. For example, if we have a tail, or if we had a head, or if we had head twice, or we had tail twice, it doesn't matter. It will always result in sample space. It will always resolve in our S. This is the S. And there is also the empty set, which is called the impossible event, because an element of empty space or empty set cannot occur at all. This can be, for example, having a tail 3 times straight. We cannot have tail 3 times straight just because our sample space does not include this event. Our sample space is restricted by tossing a coin twice. So it is impossible event in the context of our experiment. Because we cannot simply toss a coin 3 times in a row. And by using set operations and events in S, we can obtain other events in S. For example, if A and B are events as illustrated here, we can say that we have the union of sets A and B. We have the intersection of A and B. This is a simple and a basic set theory. And we have the complementary, which is designated as A prime, and sometimes it is also designated like this. So we have A prime complementary. And what is the complement to the set A? The complement to the set A, it is a set of events which is not included into A, but it is included into sample space. So in our diagram above, it will be all the space except the A. So it is all the space except the A. That's what we call the complement. So it complements the A space, the A set, to the S. That's it. Our complement space or our complement set equals S minus A. Yeah, and for sure we can also consider the difference between two sets. For example, the difference between A and B, that's very similar to the complement sets, but between A and B, this is the set which can be described as A intersection B complement. Taking a look at the particular example, we can illustrate A. For example, this one is A and this one is B, and this is the intersection of between them. And now, if we take a look at the complement of B, the complement of B is the whole space, which is beyond the set B. This one is the complement of B. And now intersection between the A and the complement of B, it is this space, which is the red one, this set. It is the complement. It is the difference between two sets. So these ones are essentially the events or outcomes which result in event A, but do not result in event B. So they will always produce only event A, but will not produce event B. So here's the key difference between them. This is A minus B. If the sets corresponding to events A and B are disjoint, their intersection is empty space or empty set. And we say that these events are mutually exclusive. For example, if we had two sets A and set B, and they do not have any intersection between them, so their intersection equals an empty space, empty set is also designated like this. We say that A and B mutually exclusive. They are mutually exclusive. And we say that a collection of events like A1, A2, A3, and so on until the AN is mutually exclusive if every pair in the collection is mutually exclusive. So these sets, these events do not have anything in common. So it could be A1, A2, A3, A4, A5, doesn't matter. But if we have some kind of AR, this one is AR, which intersects the other one, it is already not the mutually exclusive. So if we want our collection to be mutually exclusive, we need to have a separate sets, and each pair of this collection should be mutually exclusive, like this one. They don't have any intersection between them. And taking a look at the practical example, we can refer to the experiment of tossing a coin twice. Let event B or A, let event A be an event of at least one head occurs. So event A, at least one event occurs. So let's say it is head or tail, tail or head and head actually. Head in the first toss and head in the second toss. And event B, it is the second toss results in the tail. The second toss in the tail. So the first could be the head and the tail. And the second one is the tail and then follows the tail. So let's now take a look at the intersection of this, in the intersection of union, intersection of these sets. The union of these sets, obviously, 1, 0, 0, 1, 1, 1, and 0, 0. Now let's take a look at the intersection. The intersection is 1 and 0. This is it. If we take a look at the complement of set A, it will be only the tail and tail. It is the only outcome which is not included in that A. And A minus B, it is tail and head and tail. No, it is head and head, sorry. Head and head. Because these are two outcomes that we don't have in event B, in set B. In other words, for any element from A minus B, this element is not included into B. We don't have this element in B. But it's definitely something which is included in A. So conjunction belongs to A. So that's all for today's video, and I hope you found this video helpful. If you have any questions or recommendations, please leave them in the comment section below. And see you in the next episode. Thank you.